Hey guys, this is example 2 in 7.2, okay? So now that we have learned or gone over all of our inverse functions, I can give you any inverse and you are expected to find the solution, okay? So example 2, direction. Find the exact value. Again, exact value means no cow. So I'm going to, just like what we did in class, and at first anyway, we went very slowly. So what I'm going to do first is I'm going to say, hey, cosine inverse of 2, in theory, should have a value, an answer, okay? Maybe it's undefined. Maybe there's an answer that we can find. So the first thing is I'm going to rewrite this piece. If I were to rewrite it, I'm going to rewrite it in this form. Y equals cosecant of x, okay? Well, this is now the output of an inverse. That means it becomes the input of the regular. So, and this is the input, so now this is the output. So this is really 2 equals cosecant of what angle, right? So, well, cosecant is restricted. So let's talk about cosecant. Cosecant inverse is restricted, okay? Cosecant inverse is restricted to where? Can you tell me what the domain is of cosecant inverse? I'm gonna wait for a little bit. Cosecant inverse. What is the domain of cosecant inverse? I hope you wrote down from, negative infinity to negative 1, taking a little break, right? Union that with 1 to infinity. Then, of course, I will ask you what the range is for cosecant inverse. Did you write down negative pi over 2 to 0, not including 0, union that with 0 to pi over 2 in class? Okay. And when I'm asking you these questions, I don't, at this moment in time, I don't expect you to have it at the top of your head, okay? I don't expect you to have it all known or memorized. And if you don't, it's okay to look back at your notes. You just need to know where to look. So these right here are all the important stuff that you should have written it down from class, okay? So the question is, hey, what do I need to know? What is it that first, let's talk about quadrants as well, okay? What 2 quadrants do you think this is? 1, everything is in 1, that is true, and 4, okay? And not including 0, so let's check this out. So 0 is not part of my range of cosecant inverse. Okay, so everything has to come from 1 or 4. Would you agree that this is a positive 2? Red pen, positive 2. So it has to come from quadrant number 1. Cosecant, you can think of it as sine reciprocal, right? So hey, is it okay to say, hey, this is really 1 over sine of that angle? So now you can flip that. So what do you think it is? You can even think like this, okay? What if I flip this? Would I flip that? Would you agree that I need to flip this? Can I think of it like this? 1/2 is now sine of this thing, okay? These are all equivalent. This is equivalent to that, which is equivalent to that, okay? So sine of what is 1/2? Did you say pi over 6? Yay! That is true. Sine of pi over 6 is 1/2, okay? So guess what? This box now gives a pi over 6. So cosecant inverse of 2 is pi over 6, okay? And that belongs in quad 1, which helps us out. All right, now secant inverse of 2. Because this is the first time that we are using secant inverse and cosecant and cotangent inverse, I'm going to write down the equation, okay? Y equals secant inverse of x, the domain. Can you write down the domain for me? is exactly the same as the cosecant inverse. Okay, so from negative infinity to negative 1 inclusive, then from 1 to infinity inclusive only at 1. The range, do you think the range of secant inverse is the same as cosecant inverse? No, slightly different, right? The range is inclusive from 0 to pi over 2, not including pi over 2. Union that, pi over 2 to pi. Okay. So this is all of the info we gathered during class. So how do I solve this problem? Secant inverse of 2 equals some answer. Don't know what answer that is? Let's rewrite then, okay? Rewrite. This is the output of my inverse, so now it becomes the input, okay? So secant of what? Same box, right? Is 2. Another equivalency that I can think of this is 1 over cosine of this same box equals 2, okay? And if you don't feel like thinking in the denominator form, I can flip this. If I flip that, I will flip this. So this is cosine of that box equals 1 over 2. So cosine of what is 1/2, which is exactly the same as secant of what is 2. Because it is a positive number, I hope that we can see, because secant inverse is going to be from quad 1 to quad 2, not including this piece right here, pi over 2. So it's 1 or 2, not including pi over 2. Because it's positive, all answer for this one has to come from quad 1. So what should we have here? What should we fill in our box? Did you say pi over 3? Of course. Yes, it is. Okay. So guess what? Secant inverse of 2 is simply pi over 3. Okay. And how do you know that? You need to know that from our unit circle, and that's why I told you early on it was so important to have. Example 2c, let's start with the restriction for cotangent inverse. Cotangent inverse, as we had mentioned before, is restricted in quads 1 and 2. Now, as you can see, this is a negative ratio, so I'm going to get a green pen and draw out that angle. So that means the restriction is going to be in quad 2 since it's negative. Now, cotangent, so y equals cotangent of anything is going to be adjacent, right, over opposite, which is the reciprocal of tangent, because tangent is opposite over adjacent. So if you see that you have a negative rad 3, that's the same thing as negative rad 3 over 1. So your adjacent is going to be negative rad 3, your opposite leg is going to be 1, and the hypotenuse got to be 2. So this reference angle is going to give us a 30 degrees reference angle, aka a pi over 6. So pi over 6. So what's happening is this green angle right here has to be 5 pi over 6. So the final answer for this one is 5 pi over 6. On example D, it's asking us to find the exact value for cotangent inverse of 1. And again, make sure we go back and identify the restriction for inverse functions. In this case, again, quad 2 and quad 1. Now, what would make it a negative 1, right? So it has to be in quadrant number 2. So from this to here, that has to be a 3 pi over 4. So that's your angle. So what that means is your reference angle is a pi over 4, which is all the way over here. So cotangent and tangent of any multiples of pi over 4 is always 1. But the reason is negative 1 is because it has to belong in quadrant number 2. So in quadrant number 2, 3 pi over 4 is the final answer. Okay? Okay, guys, this is an example that has to use a calculator. And make sure you write down all of your steps. And I'm hoping that you are listening, because this is where a lot of kids will get the wrong answer. Okay, it seems easy, but especially when it says use a calculator, and we think we all know how to use a calculator, but this is where most of my previous mistakes are. But before I start, should I tell you a toddler joke? So this joke goes to my surfers, okay? Surfers, this is one, it's for you, dedicated to all my surfers, or my want-to-be surfers, or just people that love the beach. Why did the surfer think the sea was his friend? Why did the surfer think the sea was his friend? Because it gave him a big wave. Get it? Not like by hand, but like the wave. I hope you enjoyed that one. Example 3. Use the calculator to find the value of each. Okay. Round to 2 decimal places. First, cosecant inverse of -5. I want you to have this understanding of why we press what button. Guys, please don't do this. 1 over sine inverse of -5 is not what you can press on your calculator to get the right answer. So, concept. This is going to come out with an answer. Let's call it W, or an empty box, because I've been using an empty box quite a lot. To get an understanding of why we press what we press, I'm going to go and explain to you here. So what I'm going to do is now I'm going to write it in a normal sense, okay, a regular function, which is cosecant of W equals -5. It is true, okay, it is true that cosecant of W is 1 over sine of W, okay, which is still equal to -5. Then because I want to make that both into fractions, I'm going to put 1 underneath the 5. Well, I don't have a cosecant button on my calculator. So what I'm going to do now is I'm going to flip this, okay? When I flip it, I now have a sine of W equals -1/5. Okay? And I want to find cosecant inverse because that is still my goal. So cosecant inverse is, keep in mind now, I want to have, what do I want to have? Can I compose both sides? Of course I can, okay? All of these are equivalency, okay, because I haven't really changed anything. So now I want to compose both sides by sine inverse, okay? So, because I did compose that, this and this is now going away. So W equals sine inverse of, see, this is where I'm flipping, -1 over 5. So let me highlight this. You are not flipping, okay? You're not flipping this. See this right here? Wrong. Okay? You are flipping the ratio of the sides. So to get an answer for W, you need to punch this in. Okay? I'm going to wait on you. Can you please take out your calculator and do me a favor and punch it in? So W comes out to be what? And keep in mind, W was assigned to cosecant of -5, which you are punching in sine inverse of a -1/5. All right, box it up. Make sure you give me 2 decimal places. Make sure you give me 2 decimal places. Okay, I'm gonna go find my calculator. I need to not be in degrees, radians. There you go. Okay. 1 negative divided by 5. Answer. Now do sine inverse of that. Woo! Is that the right answer? Okay, 2 decimal places. Did I get this right answer using my old school calculator here? -0.20? Let's see. Did you guys get -0.20? -0.20. Try the next one. Secant inverse of 3. Let's make it equal to W. Okay. Then again, please don't do this. I would totally cry. Okay. Do not do that. Okay. And here's why. I'm going to try to find W, whatever W is. Okay. So first, I'm going to rewrite it using normal secant function, not an inverse one, but a normal. Then I'm going to flip. Secant of w equals to 1 divided by cosine of w, still equals to 3. Because I want to make 3 into a fraction, because the left-hand side has 1 over cosine, which is a fraction. Now I'm going to flip, okay? So now I have cosine of w equals 1 over 3. I want to get, again, I want to find w. So now I want to compose the inverse of both sides. So now w equals cosine inverse of 1 over 3. See what I'm flipping? I'm not flipping the fraction here. See this? This is wrong, but I'm flipping the 3, okay? So please help me punch that in. So now punch it in your calculator. W equals cosine inverse of 1/3, which is exactly the same as secant inverse of 3, but because you don't have a button of secant inverse, so that's why we're using cosine. So once you have an answer, can you fill that out? Let me try my calculator again. So clear this out. 1 divided by 3 equals, then I'm looking for cosine inverse, right? Whoa. Is it 1.23? Did I get it right? Did you get it right? Is your calculator in radians? So I'm going to write down 1.23. Okay. Last question of example 3. Again, I'm going to assign an answer to it. Okay. And just like the other one. Remember, this is cotangent inverse. My answer for cotangent inverse has to come from 1 or 2. Because this is a negative, so I know it has to come from quadrant number 2. And this is the most difficult one. And this is the type of question that most people will get wrong on exam. So make sure we understand. Similarly, here we go. Cotangent, I'm going to rewrite. Okay, cotangent of w equals to a negative radical 11. I don't have a cotangent button, so I'm going to try to use tangent. Cotangent is 1 over tangent of a negative 11. I'm going to make this into a fraction. Then I'm going to flip. Okay, so now I have tangent of w equals, this is the part where it's kind of confusing, negative 1 over square root of positive 11. Okay, now I can totally punch this in, okay? I can go and punch it in my calculator and get an answer for tangent. So what happens is that I'm going to, let me just erase, I just need more room. You already have this in your notes. Okay, so I'm going to find w, okay, because that's what my goal is, to get w, which is composing tangent inverse of negative 1 over square root of 11. Your calculator, okay, when I punch this in my calculator, tangent, important detail, important. Tangent is in quad 1 and 4. The negative tells me that I need to be in quad number 4, but my original is cotangent, and cotangent earlier said I need to be in quad 2. So whatever, and quad 2 is right here. Okay, quad 2 is right here. So tangent's going to give me something in quad 4. Oh my goodness, it's totally in the wrong quadrant to begin with, right? But because the calculator has a problem, it doesn't have cotangent button. The newer ones do, the older ones don't. So what happens when you get an answer? You have to go and add a, important detail, about to come out, add a pi. Okay, so make sure this is happening. So, what is tangent inverse of negative 1 over square root 11? Let's go find my old school calculator. 1, oops, that's not a 1. 1 divided by 11 square root. So that's negative 1 divided by square root 11. Okay, and then I need to take the tangent inverse. So 1.27. Oh, it's taking tangent inverse of a square root 11. That doesn't seem right. Okay, let's do this one more time. 11 square root. Okay, hit enter. Okay, so there you go. It gave me the negative 0.3015, 11, 11. Now I'm going to tangent inverse. So tangent inverse of that is negative 0.29. So I'm going to go back to where I had your recording. So this right here gives me negative 0.29, which we knew that it's supposed to be in quad 4, okay? So this is in quad 4. The important details say I need to go and add a pi. So now I need to go and add a pi to bring it back to quad 2. So go and add a pi. So go back to my calc, 3.14. I'm going to end up with 2.85 is the final answer, okay? Okay, so this answer class, this W is now 2.85 radians, and that is in quad 2. And that's our final answer. So as you know, you just saw one of the methods of finding an answer for cotangent inverse of negative 11. But remember, in cotangent inverse definition of earlier, we had, oh, it's coming up, we had method number 2. So how would that help us find the answer to this example much quicker than what you just listened to? So remember, cotangent inverse of x equal to pi over 2, take away tangent inverse of x. So what does that mean to all of us? So cotangent inverse of a negative square root 11 is identical to pi over 2, take away tangent inverse of negative square root 11. Look at that. Isn't that so much easier to find than, as you saw, I struggle with that basic calculator a lot. Now, I'm just going to go find my decimals. I'm going to enter in not cotangent inverse of negative 11. The reason I don't do that here is because most of the calculators don't have cotangent inverse. But what I can do is I'm going to type in pi divided by 2. Now, before I go that, don't forget, I need you to double check to see if your calculator is in radians. In this case, mine decimals here is in radians, okay? So now pi over 2 take away. Technically, decimals have a cotangent inverse, but I'm not using that. I'm going to use tangent inverse of a negative square root of 11. No way, it's the same answer? Yeah, of course it's the same answer, right? 2.85. Now, what if I type in straight up, because decimals is so awesome, it gives it to you, right? Negative square root of 11. Identical answer. But just so you guys are aware, most calculators don't have the cotangent inverse, so we have to use this highlighted formula right here. And honestly, your AP test is going to be asking, and when we get to second semester and we do calculus, the pi over 2 minus tangent inverse of x is what we need to know, because that's what they use. So memorize your method number 2. Let's go back, write in the answer again, and either answer is giving us the same exact decimal approximation. Example 4, write each trigonometry expression as an algebraic expression in U. So this is funny because this very same example, it's so similar to example 1. Except in example 1, you were given actual values in numbers, not U's, okay? So here we go. Tangent inverse of U is the inner component. Once you have an answer for that, you're going to find sine of that. Okay, so the whole thing is read sine of tangent inverse of U. So similarly, tangent inverse is restricted, okay, either in 1 or 4. Well, so technically, since U is unknown, you can draw out this triangle in either quadrant as long as it's in 1 or 4. No, you cannot draw it in quad 2, and no, you cannot draw in quad 3. It has to come from either quad 1 or quad 4. Since most of us love positive numbers, I would just have it drawn out in quadrant number 1. So tangent of some angle is U, right? So that's what this really meant. Tangent of some angle is really U. Well, tangent is really opposite over hypotenuse. So you can think, opposite over adjacent. So think of it as u and adjacent is 1. Okay, so now we have u and 1 as u being the opposite leg and 1 being the adjacent leg. And this theta right there is that theta. Okay, so my question is this. Okay, since this whole thing right here turns into theta, what is tangent of that? What is sine of that? So sine of theta is opposite, which I do know, over hypotenuse. Oh my goodness, I don't know what hypotenuse is, so let's find it. So hypotenuse is the same thing, a squared plus b squared equals c squared. Here we go. A squared is 1, so 1 squared is 1. B squared is u squared equals c squared unknown. Okay, well, to solve for c, you now need to take a square root from both sides. So c equals square root of 1 plus u squared. So this right here is square root of 1 plus u squared. In no class, this is not equal to 1 plus u. Okay, never, ever, ever, ever. Okay. So now I know what the hypotenuse is. I would have to put it here because it's opposite over hypotenuse for sine. Well, no, you may not leave the answer as a radical. So from here, we will need to rationalize. So to rationalize this, I'm just gonna move this over or erase that because I need some more space. I will now multiply by its radical. What you multiply to the bottom, you multiply to the top. Okay, so now we have an answer of, on the top, u times a quantity of, not quantity, times the radical of 1 plus u squared. On the bottom, it's going to be 1 plus u squared because the radical times the radical will cancel out the radical. And that is my final answer for A, with only u's left and the denominator rationalized. Cosine of secant inverse of u. Similarly, we are now going to draw a triangle, which is cosine secant is restricted in quads 1 and quads 2. And again, u is unknown, so technically you can draw this out anywhere you want, okay? Cosine, it's a reciprocal, secant inverse is the reciprocal of cosine, okay? So secant is reciprocal cosine. So this is technically what you're thinking is this. Secant of some angle equals u, okay? So, hey, cosine is adjacent over hypotenuse, okay? That means secant is hypotenuse, which is u, over adjacent. So let's find that missing piece, okay, by using Pythagoras. So we're going to say, hey, a squared plus b squared equals c squared. So a squared is 1, so 1 squared is 1. B squared is really unknown. U is now the hypotenuse, so that's going to be u squared for c. I would need to subtract both sides. Okay. So now b squared equals u squared minus 1 square root. B is now square root of u squared minus 1. Technically, I could have plus or minus, but I'm in quad 1. This is a positive value. Okay, so now that we have the opposite. So now let's find cosine of the same angle. Cosine is just going to be what? Adjacent, which is 1, over hypotenuse, which is u. What? I didn't have to find that missing leg after all. No, you did not. That's the final answer. And I love you guys all, and I will see you guys in class. Have a wonderful day.